One of the scientists who's been working on the Sunrise project since the very beginning has joined us to tell us a little bit more. A warm welcome to Achim Gandorfer from the Max Planck Institute for Solar System Research.
Hello.
Welcome to the show. Let's start with a straightforward question. What is it that's so important about solar research?
There are two different aspects. One is the question about basic science, and we are interested in solar physics because it's a standard star and we want to know how stars work. So it's a fundamental astrophysical aspect. And the other aspect is the direct influence that the sun has on Earth in various respects. One aspect is the magnetic influence, such that violent events on the solar atmosphere can disturb satellite communication, can have direct influence on our highly technicalized society today. So it is of increasing importance to understand what really happens on the sun in order to be able to predict, perhaps someday, storm warning in meteorology, to have something analogous for the sun, to keep our satellites and planes and our communication systems alive, even when the solar storm is coming.
Now, you've evaluated results from this mission, sifting through images like the ones we saw in the report. We've got some more images we're about to see just now. What new and interesting information did they provide researchers?
So what we were really surprised was, even although we have built Sunrise in order to detect and quantitatively study small-scale magnetic concentrations, and we knew there were myriads of them on the solar surface, we were surprised even how much that really is, how much more we saw as compared to former missions and further attempts. And the magnetic field is the key physical quantity to explain why the sun is a dynamic object, why the sun is active, and why the sun is not always the boring star that most people think it is.
Now, sunspots can be tens of thousands of kilometers in diameter. That's much larger even than the Earth. Yes. What can you tell us about them?
Well, sunspots are the largest manifestations of solar surface magnetic fields. We know them for 400 years. We know that they are really strong magnetic fields housing. But what we studied with Sunrise is the tiny distributed magnetic fields that in their totality clearly overrule the sunspot magnetic fields. So sunspots are the most obvious sign of solar activity, because the number changes all the time. So for example, at the moment we have a minimum, we have basically no sunspots. But that does not mean that there is no magnetic field on the sun. If you look at the very tiniest details, as we were able with Sunrise, you find myriads of small-scale magnetic fields that are not that obvious as the big sunspots, but that really carry the magnetic energy on the sun.
Now, we're almost out of time, but just briefly, what's the next step? What lies ahead?
So on the short term, we prepare for a reflight of Sunrise in phases of higher solar activity. So just get the same quality of the data, but in another phase of the sun. And on the midterm, we are preparing and designing an instrument for solar physics on board an ESA mission called Solar Orbiter that will keep us busy for the next 10 years.
All right, Dr. Gandorfer, thank you for joining us in the studio.